Uh, Hello everyone. Good evening. And welcome to today's sessions. And I'm Avik Nashwar. I'm working as a GS developer and business development executive at HSAT and Apakaja Geoscience Research Technologies. And today's webinar is very important because we are not going to do only the theory. We are going to build a real flood detection workflow in Google Earth Engine and using a real world case study from the Silchar Ashram. And it is related to the June 2022 flood events. And this session is designed in very practical way. So even if you are a beginners and you should be able to understand like what the problem we are solving and why we are solving it and what data we are using right now and how each line of code works and how this exact kind of workflow is related to the industry work. And before the start, the technical part, let me give you a very short glimpse of about the AGSAT. At AGSAT, we work on the geospatial research, GIS development, spatial analysis, geospatial solutions. We are not focused only the classroom learning. We focus on the problem solving, practical delivery, and industry alignments and career building. And we train students and professionals in the area like Python automation for GIS, full stack GIS development, utility network management, Geo AI, digital twin technology, data data processing, geospatial automation with the Pythons, and with GIS, spatial database, remote sensing analysis, and the practical project workflow used in the real organizations. So today's sessions is not just a webinar; it also the small demonstration how AGSAT teach the geospatial technology in the practicals and industry focused way. And also one of the important announcements from the starting from the next Saturday, like from the March 14, 2026, AGSAT will publish one blog in every week on our official website www.agsat.com, and also we'll also conduct one webinar every Saturday. So if you want to continuously learn the geospatial concept, remote sensing, GIS automations, Geo AI, digital twin, LiDAR, Python, and industry workflow, stay connected with us every Saturday. Okay, now let's just begin today's topic. And the today's topic is the advanced class inundations mapping using the Google Earth Engine. And now let us the first understand the problem. When a flood happen, decision maker do not have that time to waiting for the several days and they need the answer quickly. They want to know where the water spread and how much land is affected and which area are newly inundated and which water bodies are permanent river and lakes and what is the estimated affected area is. And this is where the remote sensing and GIS become extremely powerful. Using the satellite data, we can detect the flood signals even across the large areas. Then with the GIS logic, we can clean the result, mark the permanent water, remove the terrain-based noise, and estimate the area. This is exactly the kind of workflow used in the disaster management, humanitarian response, environmental monitoring, district level planning, insurance risk screening, infrastructure impact assessment, and government and consultancy reporting. Okay. So today we are not writing the random code. We are building a digital support workflow that is very important to understand. And first of all, you need to know why we are using the Silchar Ashram. Okay, because Silchar experienced severe flooding, and it is very good case study to understand how radar-based flood detection works. And now other important questions: why we are using the Sentinel-1 radar data? Because during flood, cloud is very common, and we depend only if we depend only on the optical imagery, we often lose the visibility due to cloud. And but Sentinel-1 radar data, can even work the cloud when the cloud are present, and that making it extremely useful for the flood detections. We are using Sentinel-2 optical imagery, but mainly for the before flooding visual reference in the dashboard. So today the workflow it's combined with the Sentinel-1 for the flood signal detections. The second one is the Sentinel-2 for the visual interpretations. Third one is the JRC surface water for the permanent water masking, and four is the SFTM direct slope for the trading filtering, and Earth Engine. Yeah, these are the data and Earth Engine UI components for a live analytical dashboard. Okay. This is an excellent example of how real world geospatial works combine the multiple data sets, not just one data set. Okay. What we build today, and first of all, by the end of this webinar, we will build a workflow that can define a proper area of interest, load the pre-flat and post-flat radar data, and create the composite, detect the image, and then generate the flood signal, remove the permanent water, remove the steep terrain noise, remove the tiny isolated fault detections, and calculate the flood area in hectares, and create a split screen dashboard and show a histogram of change, and show a flat area output and export the result. Let's start with the coding things. Okay. I already wrote the code, because if I going to write the code each step by step, it will take so much time, and we can cover it within the 2 hours. And for before that, I just want to show you like what is the glimpse of the code engine, like what is the result of the coding, like after coding what you get. This is the sensor area, and it is a split dashboard. You can see this is the permanent water. You can see this is the permanent water, and this is the new flood area, like where is the flood happened. And this data set, the gray data set, is the SAR data. Okay. And right now I'm going to explain the each step of the coding. Okay. First of all, here you can see this is this first portion. This is the ROI silchar, and what is happening here? First, you need to know. Okay, this is our setting blocks, and like in any good script, the setting blocks is very useful to, because it keeps the main parameter in one place. Let us understand this line by line. The first line is the var ROI e.geometry.points. Its meaning, ROI means the region of interest. Here we are creating a point using the longitude and latitude. The longitude is the 92.79 degree and latitude is the 24.82 degree. And after that, this point represents the silchar center, and then we apply a buffer here, and buffer is the 15 kilometer. This means we are creating a buffer of 15,000 meter, and which is 15 kilometer around the point. Okay, so instead of analyzing only one point, we analyze a wider surrounding study area. This is very common in practical geospatial work. We often start with a point, then buffer it, and then turn into the area for the analysis. And there is next line, you can see map.center object. Okay, center object, and this tells the Earth Engine to the center of the map on our region of interest, and number 12 is the zoom level. Okay, why do you did this? Because when the screen runs, we want the viewer to immediately see the study area. This improves the usability and save the times. Okay, then after that it's comes the data lines. First of all, here I wrote here, this is the here we define the two periods. First one is the dry baseline. It is mainly before flood, and peak flood, it is mainly after flood. The before flood is the dry baseline, and after flood is the flood period. This is a classical change detection detection strategy, we compare the signal from one time period with another time period. This is extremely common in remote sensing. We use the same concept in the flood analysis, forest loss detections, urban growth analysis, crop monitoring, drought assessments, and land cover changes studies. Okay, and the final line, it is the polarization is the BB. This tells the Sentinel-1 that we want the BB polarization band. Okay, polarization matter in the radar because different polarizations interact differently with the surface. For flooding, BB is often used because open water gives a distinct backscatter response. In simple terms, like smooth the water reflect radar away from the sensor, so the return signals become the low, and that help us identify flat-like surface. And so these settings blocks already define where we are working and when we are working and what data channel we want. This is the foundation of the full workflow. Okay, and right now after that we go with the data processings. Okay, like first of all we are loading the Sentinel-1 ground range detected image collection. Let's understand each line. The first line bar S1 e.image collection Copernicus S1 Copernicus S1 underscore GRD. This loads the Sentinel-1 datasets from the Earth engine, and image collections means many images, not just one image. That is important. And satellite analysis often not based on only one image. It is based on collection of image across the time. Okay. The next line is the filter.ein, and it like leads contents. Okay. It is mainly defined. This filter is collection. This filter the collection so that only image containing the selected polarizations are kept. Since our polarization variable is set to the BB, only images with the BB are retained. This is very important because not all images may contain the same band combination. Then the next line you can see here. The next line is the mainly this selects the image acquired in the interferometric wide swath mode, which is standard acquisition mode commonly used for the land applications. This improves the consistency in the datasets. In the real analysis, data consistency matter a lot. If you mix the incompatible acquisition conditions, your data become the unreliable. Okay. Then the next line, the filter.bounds. It is mainly this keep only images that intersects our region of interest, and the last line is the select the polarization. Okay, select the polarization. This select only the UV band from the datasets. Like yeah, again this is a good practice. Why? Because of we reduce the unnecessary data entry that keep the script the lighter, simpler, and the more efficient. Okay, and in industry projects, performance matters a lot, and a script that's run fast and clearly is the better than the script does too much at once. Okay, and then temporal median render a map style the instantly. Okay, what is happening here? Okay, now we are creating two composite image. The one for is the before flood, okay, before period, and another one is for the after period. After period. Okay. Uh, First one, let us understand the past line. Okay. Here, like here, if you see, this is the S1 filter date start before date and before end. Okay. This line, this filtered the Sentinel-1 image collection by the before flood date range. So we are only looking at the imagery between the here is the February 1st to the April 30, and it's after that it will create a median composite, and this is the very important things. Instead of choosing the single image, we are we are taking the multiple images in the data range and compute the median pixel value. And why we are using the median? Because it's helped to reduce the noise and outlier effects. In practical terms, it gives you a more stable representation and a typical condition for the period. This is common approach in the art of this observation workflow. And after that, we click by the ROI. Okay, here you can see this is the click by the ROI. This cards the result to our area of interest, and this improves the visualization and efficiency. Okay, and then we will not select 0. Okay, this line mainly. This line. What is happening here? This selects the past band and rename it as a BB. Okay, we make sure the band has a clean and expected name. And now the second line is that now the second line is doing for the after flat period and the same things. Okay, so now we have the before image and after image. These are the two main layer we will compare, and this is the heart of the temporal flat analysis. Okay, understand everyone? Till now, anyone have any doubts? Hello? Hello? No. Okay. Okay. Right now, we're just going to another one portion, that is the change detection and thresholding. Okay. Now we're performing the change detection. You can see here. Okay. The meaning of this line, it takes the post-flat radar signal and subtract with the pre-flat radar signal. So mathematically difference between the after flat minus before flat. Okay. Now why is this useful? Because flat condition usually change the radar response. Water often causes a drop in backscatter, and so when we compare after minus before and after effective surface, so we can distinct the negative difference of negative difference, and that's mean places where the signal discretes and significantly may be flat candidates. And this is very common remote sensing approach for the calculate difference, then identify the abnormal changes, and then they classify the changes, and we just rename it using the BB, and the part simply keeps the band naming consistency, and the good naming is prevent the error later in the workflow. And after that, what we did with this, that's here we like now we need a threshold. Okay, what is the threshold? Okay, a threshold help us to decide which pixel represent the meaningful flat graded change. Okay, this block calculate the summary of the statistics from the different images. Here is the main function is the difference region. You can see difference reduce region. Is this function reduce the all pixel in the region to summary statistics. Instead of keeping the all pixel individually, it calculates the aggregated value and then reducer. Here you can see this is the reducer. What is happening here? In the reducer yield or reducer mean, it is mainly this line. This is mean is calculate the both mean and standard deviation. Okay. Why these are useful? Because we want to understand the normal behavior of the different image. This mean give the average change, and the standard deviation tell us how much variability exists. Together, they help us build an adaptive threshold. and this is better than the blindly hard coding random result in many cases. Like then geometry ROI, we calculate the stats only within our study area, and then after that I scale it into 300. This is space field optimizations. We are calculating statistics at the 300-meter scale, not the full fine resolutions. Why? Because of the statistical step is only the general background estimation. We do not need to the ultra fine pixel details for this part. We make the workflow much faster and avoiding the freezing. And this is the very important practical lessons. Okay. Not every step is not every step must run the highest resolutions like smart workflow balanced speed, accuracy, and purpose. And then based on what is true, we scale the art engine to automatically adjust if the request is too heavy, and tile scale is poor. It's help the distribute the processing more safely for longer and heavier operations. And this is a useful art. This is a useful art engine techniques, tuning techniques. Okay. Okay. Then we are creating the threshold. Okay. Now we generate the threshold. This line may say saying like that, like if the statistical boundary contains dB mean, then calculate the mean minus one standard deviation. Otherwise, use a fallback value, that is the minus 0.6. Like let's understand why. Okay. First of all, here you can see there is an option that is called uh, uh, like stats contain dB mean. Okay. It is checked whether the means value existed. Sometimes in the large or problematic processing solution, a statistics may fail or return the nulls. So this check makes the script more robust. And then here you can see e dot number and this line. Okay, this line means the threshold. Threshold is equal to mean minus one multiply uh, standard deviation. Why this formula is used here? Because we want to detect the pixel that are significantly lower than the background average, and flooded surface are often show the drop in the radar backscatter. So we are looking for the values below a reasonable negative threshold. Like fallback minus zero, the fallback is minus zero because if the stats are unavailable, we use the minus 0 dB threshold backup threshold, and this is the defensive programming practice. In the real world workflow, you should always prepare for a failure cases, and that is how the professional scripts are written. And after that, we are just going to creating the flat signals. Okay, what is the flat signals and why we are using this? This line creates a primary flat mask. Okay, this is LT. This means the less than. Here you can see LT. The LT is means the less than. Okay, and yeah. So this line is checking which pixel have a difference value lower than the threshold, and those pixels are marked as a flat signal candidates, and yeah, flat signal candidate, um, and this is not create the final flat map. This only the initial detection layer. Okay, why not it is the final? Because many things can create the false signal like permanent river, current effects, noise patch, isolated speckle like clusters. So we are now moved to masking and cleaning the data. Okay. First of all, what is the masking? Okay. Okay. First of all, like okay. Before the masking, I just want to go with another one thing that's before the continue. Uh, uh, like let me connect this with the real world industry practice and with the with what we do at AGSAT. And Like what you are seeing right now is not just only one flat script. This is a combination of the remote sensing understanding, GIS logic, data cleaning, decision support thinking, and performance optimizations. This is exactly how the geospatial professionals work in the real projects. At HSIT, we train the learner not only to run the tools but understand why a workflow is designed in a particular way and how to optimize it, how to make it robust, how to make it useful for organizations, and how to convert the technical analysis into the career ready project skill. Our like again, I am just our course cover the Python automation, full stack CS development, infinity network management, Geo AI, digital twin technology, LiDAR data processing, geospatial automation using the Pythons, and many other industry aligned topics. And we also provide the 100% placement assistance and internship opportunity so that students do not remain only the learners but become the employable professionals. If you are serious about these things, like about the geospatial career developments, and please connect it with the HSRT. And once again, from the Saturday, March 14, every Saturday we will publish the one blog on www.hsrt.com and another one webinar. Okay. Now let us continue the technical workflow. Then this is the masking is the permanent water masking. Okay. First of all, what is happening here? Okay. Now we remove the permanent water. We are removing the permanent water here. You can see this is the permanent water masking area. These portions. What is happening here? First of all, we remove the permanent water. This is extremely important. If we do not remove the permanent river or lakes, we may incorrectly count them as a flat. The first line is showing that the we are loading the this is the load the GRC global water service datasets. This is very useful reference datasets. And the next line, what is happening? Like let's yeah, this occurrence the band tells us how often water has been observed historically. Like even that's inheritance GT means greater than 80. It means greater than 80 percentage of occurrence. So occurrence. So if the water is present more than 80% of the time, we treat it as a permanent water bodies, and then unmask like fills the missing area with the zero, and with this make the mask more stable. Okay. Then new flat. The new flat is means is the keep the flat signal only where the only where the uh, uh, only where the permanent water is not present. This is very important concept in the classification workflow. First detect the signal, then remove the known non-target classes. This improve the predictions, and in the real projects using the external reference layer like this is a strong professional practices. Okay. Then after that we just created the terrain masking. Okay. The terrain maskings here in the past line what I did here. This loads the SRTM dim and calculate the slope. Why do we care about slope in the flat mapping? First of all, you need to know because flat water usually accumulated in the flatter terrain. Very straight area are likely to represent the stable flat spared. In this typical region is inundation. In this type of regional inundation analysis. And next line here, what I did here. Here I did this. This line is meaning is the this means is the keep the flat pixel only where the slope is less than 5 degree. You can see the slope LT 5. It is showing that and this is remove the many unrealistic detections. Again, notice the logic. First we detect the change, then remove the permanent water, then remove the steep terrain noise. Okay, this is how a practical workflow becomes better than raw output. Okay, then final connections. It is the final connections. Now we are cleaning the result further. This line, the bar connections, this line is calculate the number of connected neighboring pixel, and this help us to identify whether a flat patch is part of the meaningful cluster or just a tiny isolated peak. Okay. The next line, final flag, it is this keep only the cluster with the at least 10 connected pixel. Okay. Why we do this? Because the tiny isolated detections are often noise. This is commonly post-processing strategy in the raster classification. In professional mapping, raw output is very rarely final output. Cleaning is the part of the job, and this is one of the biggest difference between the beginner works and industry quality works. Okay, then we are going to another one step, that is the area calculations. Okay, here what I did here. First, the first line is representing like this convert the binary flat marks into area. How? First of all, you need to know here you can see e dot image dot pixel area. It gives the area of each pixel in square meter. When we multiply the flat mask by the pixel area, flat pixel become the area values. So now every flat pixels carries its area. The next block, here you can see this one. This sum all the pixel areas inside the RY. So uh, so now we get the total inundated area in square meter. Again, uh, like here you can see this is the mac pixel. It is the high resolution. Is the high enough for the big computations. The best effort. It's help avoid the failures, and the tile scale. It support the stability. Okay, this is a very professional practices. Okay, then here is the next line. The raw area. This retract the sound area values, and the final line is the area in hectare. Sorry, area in hectare. Uh, okay, uh, like uh, like this raw this raw area is null. Use the zero. Otherwise, use the actual area. Then divided by the 10,000. Okay, and after dividing by the 10,000, convert it into square meter to the hectares. Why hectares? Because the hectares are very commonly used in land, agriculture, and environmental and disaster reporting. This makes the result easier to communicate with the decision maker. And then we are going to another one part of the last part of the coding, that is the dashboard making. Okay. First of all, what I did here, dashboard making. First of all, now we are creating the dashboard interface. This makes the screen more communicative and more stable in the presentations. Then you can see this is the left map. This left map, this will hold the before flag reference view, and the right map, it will hold it will hold the radar result and detected flag. And then I give here the linker. Okay, this linker is the synchronize the map. So if we pan or zoom one map and other follows, this is very useful for the comparison dashboards, and this is also a nice functional touch when you representing the analysis to the client or stakeholder. And then after that, after that here here now we load the Sentinel-2 data for before flat visualization map. This is very important part because it is also show the common error and fix. Okay, the main line is the Copernicus is to SAR. This one, it is mainly it loads the Sentinel-1 surface imagery, and then depth filter. I am giving the depth filter from my before flat area, and this matches the pre-flood baseline periods. And then this is keeps only the like this one is keeps only the less cloudy images, and then like isolate only band 4, band 3, and band 2. This is this is done before the median. Why is that important? Because sometimes different images may carry different band structure or metadata conditions. Selecting the required band fast, ensuring the compatibility. This helps prevent to common earth engine error and incompatible bands. Then I read the median and ROI and click by the ROI. Creates a median composite and click by the click it by, to the ROI. So we have a clean true color style optical image for the pre-flood visualizations. Okay, and after that, okay, after that, now we start the visual communications. The left nav add layer, the first line. You can see the first line. It's mainly this adds the sentinel to image, the minimum and maximum value, control the display stretch. Then left map dot add EY, that is adds the label for the clarity, and then right map add layer. It show the post flood radar intensity, and also the post flood radar intensity. And here you can see this is the right map add layer. This is the permanent watermarks. It show the permanent water in the dark blue, and the final, and it is the final flood layer. This show the newly detected flood area in the red, and then label it. This is the label. Like again, it's improve the interpretability. Notice how important the colors and labelings are in GIS communications. Analysis is not enough. The result is must also be understandable. Okay, and after that, the speed of splitting the panels. You can see here. Okay. Now we are creating the speed comparison panel. Okay. First of all, the first line bar speed panel. This creates a slide by slide comparison interface. Like wipe this wipe is equal to 2. It is mainly showing like it is it means the user can slide the across the map, and this is very effectively for the visual storytelling. And receive the route. You can see reset the route, and in the second line, this replace the default interface with our custom speed panels, and then we are just going to left panel and center objects. This ensure the study area is visible in the custom UI. Okay, and then report panels. Here you can see this is the report panels. This much. In this report panels, this is where the dashboard become more than a map. It's become an analytical presentation of interface. For the first one, this bar panel is equal to UI panel. It creates the floating panel positions. This one, floating panel positions, and at the bottom right, and this black semi-transparent background make it readable on the top of the map. Okay, and then here you can see this panel dot add UI. It's mainly it gives a title, like here I am showing here I write here the Silcher flood AI report, that kind of things, and this give you a report like title, and then subtitle. For the subtitle, here I add here the panel dot UI automated impact analysis June 2022, and this explain the what the report represents, and what this type of interface useful for the demo, stakeholder meetings, training, internal dashboards, and storytelling. And then we are creating a histogram. Okay. Okay. Now we add a histogram of the change value. This is very useful because a map alone does not always tell the full story. A histogram helps us to understand the distribution of the different images. The first one is the like UI chart dot image. This line. This line is generated the histogram for the different images. The input is the image difference. Okay, means use the change layer. First, the second one is the region RY, means the only within the study area. Scale is the 300. Okay, improve the performance. Minimum bucket width is the zero point 0.5. It is control the bin size. Okay, and then we use the seed option. Can you see there? The seed option. It is these options are mainly for the styling like title, colors, axis formatting, background formatting. The purpose to make the chart readable and in a dark panel, and this is a strong presentation skill. Your output should not only work with technically, it should also work clear and professional. Then I add the panel. This chart adds the histogram into my report panel. Okay. Then area level you can see. Okay. Okay. What is happening here? First of all, you need to know. Like we are displaying the total inundated area. Okay. The bar area text, the first line is representing this creates the placeholder text while the Earth engine compute the area and evaluates it using the per hectare evaluates using this. This is important because the Earth engine use the server side object to bring the final value to the UI as a client side value. We evaluate. We use the evaluate inside the function. If there is an error, we show as a estimated fallback text. Okay. If value is exists, we show the value in two decimals, and otherwise we show as a zero. This is practical coding. This is a good practical coding, and UI code should handle the success, failure, and null conditions. Then we add the small label, that's panel dot panel dot UI dot label total inundated area. Then then the big area resulted as a text. Okay, in the panels, and now the report panel can show the flat area in hectares. And after that, here I created here a legend function. Okay,
Sir, if you show us the what function is working how, if you show us that layer also, it would be very helpful.
Yeah, I will show. I will show after the explaining the full code. Then I will show that everything layer and how it's working and how everything in the panels. Okay. Hello.
Okay. If it is in between, then we can understand what code is doing what. So
Okay.
yeah.
Okay. Just one second. I'm just like for this year. If you see this, the first one is this is the let's take from here. Okay. I think the previous thing you understand that what are the pixel I used here, what are the data I used here, and after that, for the main chart. Dashboard. Yeah, this one. Okay. If you see here, this is dashboard UI. Okay. What is here? It is happening. The left area is the this left area. It is the before flat reference view. Okay. And the right area is this is called the radar result and with the detected flat. Okay. And here we just synchronize with all the maps, and if you zoom, if you pan, and everything will be the same. It will gonna take some time to load the map. You can see it is loading right now. Okay. Then this is Sentinel-2 visualizations. I already told you that like it is like mainly now yeah, it is mainly like showing the before image portion here. Okay, this one is the Sentinel-2 images. Using the Sentinel-2 images, we can detect that what is the before image portions like and these things. And then this the left map at layer prefab visualizations. It is for the like visual communication. It is happening here. Like left map, the at layer. It is like the left map. It is showing showing that what is the max value and what is the minimum value of the image, and it is the prefab visualizations. And then left map UI, it is the before normal and bold, it should be like that. And then right map visualization is the raw radar data. This is the Sentinel-1 data with the dB, and maximum is 0 and minimum is minus 25. And after that, the permanent border, you can see this is the permanent border masking we did here. This is a permanent border masking, and the permanent border is showing here. And uh, then final map. This is the new flat extent. If you see this, the new flat extent is the red area is the new flat extent. It will show as a new flat extent. And then right, this is the after flat detected positions and bottom right and from. Okay. And after that, and after flat, like uh, yeah, okay. And how much flat area is detection detected here, and it is also showing here. Okay. And after that, we split the panels. Here we are just going to split the panels of the area. Like this is the splitting the panels. Like here we are creating the split panels. Like we can create it. And after that, like report panels. This is the report panel. Like if I zoom in the report panels, we here you can see this is the bar panel. This one, the report panel, bar panel. Here is the report like title here, which is with the Silchar AI report. It is show here the Silchar AI report. Also, it is showing the second option. This is the automated impact analysis. Like this is also showing the automated impact analysis of the June 2022. And after that, the backgrounds, giving the backgrounds colors, and the histogram, like all the colors I give here. And after that, the histogram, I just want to add here the report panels. For the histogram, like here I use the his chart. Like it is showing like the like uh, like distribution of distribution of different image. Like if you see the histogram, here is the difference. Like from the this is the different image of the from the different date. Like it is the BB count is -5, BB count is 3, BB count is -1.5, -0.5, then -1, 1, then this one is the 0.5, 0, 1, and that kind of things. BB count is there. Okay, this is the histogram. And after the histogram chart, if you see this is the state options, title, color, axis formatting, and background formatting. And after that, the area labels and evaluate. That's if you see this the area text. This is one is the area text, and also I add here the total inundated area, and it is the total inundated area as my top panel in my panels. And after that, I add that area of the text. Okay, and yeah. And after adding the area, the last option I give here the like just one second. Uh, where is the area? Okay, okay. Uh, After area text, I give here the legend functions. Like legend function is create the legend options like the new flat disaster and permanent river. There is two type of legends I adding here. And after the adding the label functions, here you can see this is the option for the add panel to map. Okay. Just right map. Mhm. Yeah. Right map add panel, here you can see after the right map add panels. This line that attach the report panels into the right map. And now the map is not just showing the layer; it is showing the compact chart reports. And after that, here you can see this is the export option. Like this one is the like what are the export description, like we are exporting the result into the Google Drive. This is very useful, important because the analysis is useful only when you can be delivered. And the image is like final flat, and this is the final process flat layers. And description is the like here I give the filter fast map, and this is the final process flat layer. And after that I give the scale in the tens, and this set the output resolution to the 10 meters, and the region is the RY. This keep the export limited to our study area, and export is a key part of the professional workflow because clients, team, and decision maker often needs a intuitive output, map ready raster, and GS layer, and reports and derived product from the other software. Anyone having doubts, guys? Then I will go to the next part to creating the application from you. Hello. Okay. After that, you have to click on the apps. Here you can see this is the apps options, and here you can see this is the new app options. Okay. After clicking on the new app options, you just go to the next, and then you just give your app name, that feature, and then go to the next again, and you can upload your logo also if you want to, and you can publish it. Okay, and view the gallery. It will take some time. Okay, that time we just like what we did here. First of all, I just want to put the finish the all the things, like just conclude all the things. Like first of all, what we achieve from here. With this workflow, we have the defined the area of interest. First one, the second is the loaded radar data created before and after composite, detect the backscatter loss, then build the threshold, identify the possible flood extents, remove the permanent water, remove the street terrain noise, remove the tiny isolated patches, and calculate the inundated area, and create a dashboards and prepare for a exportable output. Okay, this is a very good example for the real geospatial problem solving workflow in industry. The similar logic is used for the real-time response, the district administration supports, flat pen monitorings and pen monitorings, infrastructure risk assessments, insurance training, environmental consultings, and operations remote sensing service. So what we learned today, it's not the code. You learn the date selections, change detections, masking logic, and post processing and area estimation, and dashboard communication, and export ready workflow again. Okay. Uh, just like let's see it is created or not. Application. Okay. It will take some time to load the data. Unauthorized, this is the GE applications. Okay. Okay. In the sense, last questions, like, just I just want to remember once again, like, this is the exactly the kind of thinking we emphasize at the HZT, and we do not teach only the button clickings, and we teach the how the understand the problems, how to select the right data, how to write the clean logic, how optimize the workflow, and how to make the outputs presentable, and how to align the learning with the real project events. And our training is included the Python automations, full stack development, utility, Geo AI, digital twin, uh, digital twin and WebGIS spatial database, remote sensing analysis, and industry-oriented geospatial workflow for students and professionals who want to build a career in the like properly. HST is focused on the practical implementations and project-based learning and career alignments. And we also provide the 100% placement assistant and internship opportunity. So if you are want to move beyond the basic GIS and enter the real world project work through this kind of ecosystem we are building. And so remember every Saturday we are starting that one blog, releasing one blog on edizati.com website and one webinar every week. And thank you for everyone for joining today's webinar. And I hope the session is help you for the learning. And if you want to connect with me for the geospatial career development, yes, learning guidance, courses, projects, internship related queries, placement supports, or any kind of geospatial discussions, you can contact me directly. This is my contact number 978 921 and 2166453. And please stay connected with HZT for the weekly blog, weekly webinar, and geospatial career support and advanced GIS learning opportunities. Thank you once, and we will see you in the next session.